All right, guys. So I'm going to start this stream off with a problem a former student sent me. He's in business calculus. It's not a real lengthy problem, but I couldn't really send it through text on how to explain the whole thing. So I'm going to start this off with the business calculus problem. In this business calculus problem, he's given a cylinder, and he's told that the volume of the cylinder is 1. Well, volume is just pi r squared h equals 1. Of course, the radius is down here, and then this is your h. Then he's told he has to minimize the cost of this, and he is told that the lateral surface area is the part that goes around this way, is 2 pi rh. 2 pi rh. So that means my total surface area of this barrel is going to be my lateral surface area, 2 pi rh, plus 2 times the area of the bases, which is just pi r squared. So it's the total surface area. Then he's actually told the circular part, so the bases, my bases, cost $9 per square inch for the base, and then the edges, the lateral surface area part, my lateral surface area part, costs $18 per square inch, or per square meter, whatever it was. The units don't really matter. So on this, it actually asks him to write a cost function. Well, the cost function is pretty straightforward. So the cost function for this is going to be, my lateral surface area is going to be 18 times 2 pi rh plus 9 times 2 pi r squared. All right, so from here we can kind of clean this up. My cost is now 36 pi rh plus 18 pi r squared. That's easy enough. Now the key to this is I have two variables. I got to get it to 1. That's where this formula comes in play. I can rewrite this formula in terms of h, so I could substitute it in. So I can actually get h equals, if I divide everything by pi r squared, I get 1 over pi r squared. So I substitute that in for my h, and I'm going to get my cost in terms of my radius is going to be 36 pi r times 1 over pi r squared plus 18 pi r squared. Now the pi's cancel out, the squares cancel out. So my simplified cost function is the cost in terms of radius is going to be 36 divided by r plus 18 pi r squared. Okay, this is the algebra part of it, not the calculus part. This part's just algebra and substituting and get it into a single variable. So here's my cost function, so I know how much it's going to actually cost based upon the radius. All right, so from here, we need to minimize this. It says, what is your minimum cost? Because if you're in business, you want to spend as little as possible and charge as much as possible so you can have a profit. So we need to minimize this. So to minimize it, we're going to have to take the derivative. So I'm going to rewrite this in terms of exponents, and I'm going to get my c. I'm just going to write c equals 36r to the negative 1 plus 18 pi r squared. All right. Now from here, I'm going to take the derivative, which is going to give me c prime, which is going to give me a negative 36 r to the negative 2 plus 36 pi r. Now from here, this tells me the slope. So a minimum and maximum is at a slope of 0. So I set this equal to 0, and I get negative 36 r to the negative 2 plus 36 pi r. From here, we're just simply solving for r. It's pretty easy. So we're going to do 0 equals, let's see. Let me just do it this way. Negative 36 over r squared plus 36 pi r over 1. Add our fractions by getting a common denominator. So I've got 0 equals, I'm going to have an r squared. So it's going to be a negative 36 plus 36 pi r cubed. R cannot equal 0 because I can't have a 0 in the denominator. From here, I just simply have 0 equals negative 36 plus 36 pi r cubed. Yeah. From here, I'm gonna rearrange this and factor out of 36. I got 0 equals 36 times pi r cubed minus 1. Divide both sides by 36. That gives me 0 equals pi r cubed minus 1. Solve for r, and I see that r is going to be the cube root of 1 divided by pi. That's easy enough. One step of calculus, the rest was all algebra. Pretty straightforward. So this actually tells me my r is approximately 0.6827, whatever the unit is, that's what the radius is going to be. Now, to check to make sure this is a minimum, I actually do what's called the first derivative test. So I want to put a number line here, and I want to put a number here, this 0.6827. I want to pick a number smaller than 0.6827, but greater than 0, because my radius has to be greater than 0, and I just happen to pick 0.5. And then I need to pick a number greater than 0.6827, but less than 1, because my volume, I just leave it like that, and I have 0.7. What I find out is that this is a negative slope, and this is a positive slope. So if I were to actually graph, what's actually happening on this graph is the graph's coming in here, then it has a slope of 0, and this graphing up. So indeed, this is actually a minimum value. So the minimum value for my radius, which will minimize my cost, is going to be this 0.6827, blah, 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 blah. Now, to actually find the height that the last bit of the problem asked for, is just simply taking this r right here and plugging it back in here, so I can get my height equals 1 over pi times my r, which is 0.6827 cubed. Now you can use the exact value as well, because I know you're in college, so it may need the exact value. But when you put this into the calculator and crunch it out, you get 0.6830 is your height. So you actually have the radius and height of your cylinder. That's going to minimize your cost. Pretty basic problem, really. I mean, I didn't really use business calculus. I used regular calculus. This is fairly early in calculus. Hopefully that helps you out, my former student.
When you're done erasing, you need to get the I don't know what class. Hold on.
Who's that?
Class? He was day 5, page 1, number 4.
He's algebra 2.
Okay.
Wait, yeah. Well, no, because somebody under that was actually asking me pre-calc questions. So, yeah, is it algebra 2 or pre-calculus? You remember working problems like that in calculus?
Yeah. Especially that first derivative test.
Mm-hmm. Wow, this orange, I'm going to switch colors. This orange is hard to erase.
Algebra 2.
Algebra 2. All right. As soon as I'm done working my arm out, my right arm is going to be so strong after erasing this board over and over and over again. Oh, boy, I'm not using that orange again. That orange was brutal to erase.
Did you put a first comment?
Can you help me with English? No.
And I'll put it underneath.
Oh yeah, that's pretty funny. Actually, what I found out, I'm not as bad at English as I thought I was. So we're going day 5, page 1, number 4 and 6. Day 5. You must be talking week 1. You talking week 1? Oh, he's probably talking this one. I think it's this week. There's not 5 pages for this week. Oh, wait, yeah, there is. Never mind. I'm thinking next week. Hey, next week I went easy on you. You only got 3 pages. Okay, so number 4. Let's start at number 4. All right, number 4. 8x cubed minus 1. Well, hey, that's a difference of cubes. Over x plus 2 times x squared minus 4. Hey, that's a difference of squares. Over 2x squared minus 5x plus 2. Okay, first thing we got to do is factor everything. Rational functions, factor, factor, factor. This is the difference of cubes, which is a cubed minus b cubed, is going to equal the a minus b, a squared plus ab plus b squared. It's a special factor. So my a is actually 2x because this 8 is actually 2 times 2 times 2, so it's 2 cubed. So this top part here factors to 2x minus 1 times 2 times 2 is 4, so 4x squared plus, well, 2x times 1 gives me 2x, and then 1 squared is plus 1. Okay, so there is my very first top factor. All over x plus 2. Darn, nothing cancels out. What was I thinking? Okay, and then from here, the difference of squares, this factors to x plus 2, x minus 2. That's easy enough. This right here, I'm going to have a 4, which will give me a -1, -4. That's going to give me my -5. So to real quickly factor this, I'm going to have 2x squared minus 4x plus a -1, or plus a -x plus 2. This gives me a 2x, and then that gives me just simply an x minus 2 minus an x minus 2. So this one factors to a 2x minus 1. Hey, look at that. And x minus 2. Hey, look at that. Wow. Okay, now that we got this fully factored, let's look at the domain first and foremost. What numbers can I not have to, I can't have in this? Well, all we do is we set my denominator is equal to 0, or not equal to 0. In this case, we know that x cannot equal, let's see, this has got to be -2. This is going to be 1/2, and this is going to be 2. Just let those equal and solve them. They're just linear equations. I'm not going to take the time to do that. Now let's simplify this now that we know what x cannot be. So we'll look up and down. Nothing here is the same. Hey, if I look up here, up and down here, those are the same. They go away. Now because we're multiplying, we can actually go on the diagonal. So I look at the diagonals here. Hey, look, this goes away and this goes away. So this whole bottom becomes a 1. Hey, wait, x plus 2 and x plus 2. This goes away and this goes away. So by the time I'm done simplifying this, I'm just simply left with 4x squared plus 2x plus 1 times 1, which I'm not going to write. That's your answer. Your domain is the set of all x's such that x is an element of the real numbers, and x cannot equal these numbers right here, -2, 1/2, and 2. Done. It's all about factoring and canceling. That's almost how I have this whole page set up. Factor and cancel, factor and cancel. All right, so that one's done. Not a problem, Ethan. Hey, if you have other friends or if you need other help, you know where I'm at. And then I'm doing this live stream Monday through Friday so they can come on here and ask me questions. All right, so that's an OBS issue, and I've been looking into fix that, but I have to go in and mess in with the drivers and the BIOS on my computer, and I don't want to do it. Oh. So there's a fix for it, but it's a very technical fix, and I don't want to go in and screw up my computer. No, I don't remember it doing it. Sometimes it does it. Sometimes it doesn't. It just is what it is. Yeah, it's hard at work. Do you have like a page worth of work? Oh, this blue comes off so much better. Factor, 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 Garen. Factor, factor, factor.
He's trying to set the denominator to be.
Nope, that's only when you add and subtract, buddy. All right, and then he wanted to. He wanted number 6 also. Yes. All right, let's do 6. Wait, that was 6. No, it wasn't. It was 4. All right, 6. All right, so here we go. 6. X squared minus 25. Hey, that's a difference of 2 squares. Over 2x squared plus 5x minus 12 divided by x squared minus 3x minus 10 divided by x squared plus 9x plus 20. Okay, you probably can guess at this point, I'm going to say factor everything first because it's rational functions. You're going to factor everything. That's how I set this up. All right, so my top here factors 2, x plus 5, x minus 5. The bottom here, let's say I've got 2 and negative 12s on negative 24. I'm looking for a 5, so that's going to be what? 8 and 3. So positive 8, negative 3, that gives me a negative 24 and a positive 5. So I'm going to do 2x squared minus 3x plus 8x minus 12. Group it. I have an x here. This gives me 2x minus 3. And I can take a 4 out, so plus 4, and that gives me 2x minus 3. So my bottom here factors to x plus 4, and then 2x minus 3. And then I'm going to divide. Let's see, this is 2 and 5. So this is going to factor to x minus 5, x plus 2, because negative 5 plus 2 is negative 3, negative 5 and 2 is negative 10. This has got to be 4 and 5. So this is going to be x plus 5, x plus 4. 5 and 4 gives me 9. 5 times 4 gives me positive 20. Now I'm fully factored. Okay, so you can see this is a lot of factoring. Now, right off the bat, let's note, what numbers can x not be? I know x cannot be negative 4. This is going to be 3 halves. This is going to be negative 5. And this is going to be negative 4. All right, let's look up and down to see if we can simplify before we do keep, flip, change, or keep, change, flip. X plus 5, there's nothing here that simplifies, nothing here that simplifies. That's perfectly fine. All right. So now we're going to change this to multiplication, and we're going to take the reciprocal of this. So I have x plus 5, x minus 5 over x plus 4, 2x minus 3. Change the division to times, take the reciprocal of the other. X plus 5, x plus 4, all over x minus 5, x plus 2. Okay, let's go back and look real quick because I flipped and I have things on the bottom now. Let's see, x now cannot also equal 5 because that would make this 0, and it also cannot equal negative 2. All right, so let's look and see if we can cancel anything. I got an x minus 5 and an x minus 5. That's gone. I have a x plus 4 and an x plus 4. That's gone. So that just simply leaves me with x plus 5 times x plus 5 all over 2x minus 3 and x plus 2. From there, you can FOIL it out, do whatever. I'm not going to finish it out. That's the whole process. Now at this point, it's just FOIL or the box method. So the domain of this is going to be the set of all x's such that x is an element of the real numbers, and x cannot equal all of these numbers. So let's see, we've got negative 5, so that one's done. Negative 4, well, I had it repeated, so I don't need to write it twice. Negative 2, 3 halves, and 5. And there's my domain. Not terribly bad. Got to factor, got to cancel. Factor, cancel, factor, cancel, factor, cancel. It's a 3. Get over it.
Something over.
It's a 3. Get over it.
It also needs page 2.
Page 2, number 10. All right.
I'm assuming with this week.
Yeah.
Since he's already asked.
That orange was really hard to come off. My arm is sore. I am being a baby.
My friend left.
Because he wants to hug the camera.
No, his allergies are bad. He just moved to put it. He just shifted something. Bottom.
Everything still looks fine. There's something green. Oh, it's my monitor. It's not my monitor. What is that? Oh well, we're just gonna roll with it. All right, page 2, number. don't know what that is.
We'll
It's
figure it out
somewhere
later.
up here. Figure it out later. All right, page 2. So, Garen, you said the orange didn't show up real well? On page 2?
Yeah.
There's not 9 problems on page 2.
Page 2, number 10, 9.
There's not a page 2 on this week. Because the page 2 of this week only goes to 6.
Oh, you're saying that the orange shows up the color because of the LED lights. The colors.
Oh, yeah. And then the next one only has 4 problems.
Third week.
Week 3? Pretty sure that's what I'm on. Yeah, I'm on week 3. What day? Week 3, day what?
Steph?
Day 5, Okay. Now he wanted 9 and 10?
Yeah.
I'm not working both of them, buddy. I will work
for 10 first.
All right, I'll work 10 because 10 is actually kind of fun and it's got a little twist to it. Okay. So, here we go. 10, let me give myself some room, is 1 minus 4 over x plus 3 over x squared all over 1 minus 9 over x squared equals x minus 1 over x plus 3. And I'll tell you to solve for x and check for extraneous solutions. So first thing I'm going to do is I'm going to look and see, okay, I've got fractions everywhere. What can x not equal? Well, I see that x can't equal 0. That's for sure. Because I'd have a 0 here, I'd have a 0 here. So I know x cannot equal 0. I know x cannot equal negative 3 because of this. All right, easy enough. Let's start simplifying. So to get a common denominator here, I have to multiply this by x and this by x squared. So I jump to the step of x squared minus 4x plus 3 all over x squared all over. This here is going to be x squared minus 9 over x squared equals x minus 1 over x plus 3. Okay, so now let's look at my denominators. What can't I have? 0, 0, and negative 3. So far, so good. So let's simplify. These cancel out if you keep flip and change. And this reduces down to x squared minus 4x plus 3 all over x squared minus 9 equals x minus 1 over x plus 3. That's not a 3. Now it's a 3. All right. So now let's factor, because we can factor. And my top factor is 2x minus 1, x minus 3, all over x plus 3, x minus 3 equals x minus 1 over x plus 3. Hoorah! All right, now let's look. Is there any extra numbers I need to add into my domain restriction? And there is, because x cannot equal 3 at this point. That's easy enough. So far I know that it cannot be 0, negative 3, or 3. And let's simplify. Let's look up and down here. Simplifies. And this just simply leaves me x minus 1 over x plus 3 equals x minus 1 over x plus 3. All right, if you see what's happening at this point, you could stop. Or you can see you have the same denominator. You can write this as x minus 1 equals x minus 1, or you can stop. Or you can add 1 and add 1, and I get x equals x. That seems simple enough, right? What happens with x equals x? Well, if you remember from Algebra 1, if you get a true statement, you have infinite number of solutions. So this problem actually has an infinite number of solutions, excluding 0, negative 3, and 3. So your actual answer for x actually, the answer is your domain. It is the set of all x's such that x is an element of my real numbers, and x cannot equal negative 3, 0, and 3. It is a beautiful problem because you have to remember something from Algebra 1. If you remember from Algebra 1, if you got something like 4 equals 0, this was no solution.
You said all real numbers?
Yeah. It's every real number except for those. This is no solution. If you get x equals any number, it is one or solutions, or it's discrete. It's the number of solutions. Cannot spell.
Oh, wait.
If x equals x, what do I mean is something's happening? If x equals x, or like 1 equals 1, these are infinite solutions. Whatever. So if you remember this from Algebra 1, then you wouldn't have, you could have stopped right here. Because right here, you see that this is basically this. It's infinite solutions, because they're exactly the same.
But please don't use it.
Why? This is fun. Why do I want to work number 9? I'll work 9.
And then they said, no.
This is so much fun. Just ask you to remember something from.
He said, please don't.
Just ask you to remember something from 2 years ago.
Please don't. Haha, that was not erasing very well either.
Wow.
I sat here longer because of this.
Since nobody else is asking questions, I will work number 9 for you. Walk you through number 9, because 9 and 10 are actually.
Listen, I usually finish all my work by 2 or 3. That's a good thing.
That is a good thing.
That way you can just relax for the rest of the week. Not all your work is done.
Paper down.
Wait on the Xbox right about now.
Well, I'm keeping you from your Xbox. That doesn't hurt my feelings one bit.
5 o'clock, okay? Want me to do it earlier?
Did you hear it, Garen? You want me to do this earlier so you can get to your Xbox? All right, number 9. Number 9.
Aww. Alex said Cody looks cute, doesn't he?
Oh, so she's awake.
And he's the social distance.
All right, so we have 4x over x squared plus x minus 6 equals 7x over x squared minus 5x minus 24. All right. Garen, you're from Louisiana. Oh, yeah. All right, so you can probably guess what I'm going to say. Factor. So we have 4x over x plus 3, x minus 2 equals 7x over 5 and 3. No. 6 and 12. No. 8 and 3. X minus 8. X plus 3. Wow, I had a brain fart there. This gives me my negative 24, and it gives me negative 5. He's mad at you now. Now he's going to move my camera. All right, so from here, what we need to do is we need to look and see, we need to create a common denominator across this so we can use the property of equality. If I look at this denominator, I have an x plus 3, x minus 2. This has got an x minus 8, x plus 3. So if I multiply this by x minus 8 over x minus 8, multiply it by the number 1, I will be good. X minus 8 divided by x minus 8. This will actually give me a common denominator here. I have an x minus 8 and x plus 3. It's missing the x minus 2. Multiply it by 1. So now when we multiply our fractions, we multiply straight across. So this gives me 4x over 8 minus x minus 8, x plus 3, x minus 2. And that's going to equal, well, times x minus 8. Sorry about that. And that gives me 7x times x minus 2 all over my x minus 8, x plus 3, and x minus 2. Okay, So we have a common denominator. At this point, we can actually look at my domain restrictions. My domain restrictions, x cannot equal, let's see, 8, -3, and 2, because that would make zeros in my denominator. Now, we can use the property of equality. I also call it the one-to-one property. They mean the same thing. The only way for this to be true, because my denominators are the same, is my tops have to be equal. So I simply do 4x times x minus 8 equals 7x times x minus 2, and I solve. This gives me 4x squared minus 8 16 is 32. 32x equals 7x squared minus 14x. Let's put everything all on one side. So I've got -3x squared. What is that? 20, no, it can't be 28. 18. Minus 18x equals 0. Factor. How many x times -3x minus 18 equals 0. 0 product property. X equals 0. -3x minus 18 equals 0. What?
He's mad.
He's mad. And then from here, we're going to add 18, divide by -3. I get x equals 6. So because these are not in my domain restriction, these are going to be my solutions. So x actually equals 0 and 6. It's the set of. And then, did I ask you for the domain on this? I did not. And I said check for extraneous solutions. You could technically plug these back in here and make sure you're not dividing by 0 and you get a true statement and all that. But as long as this is fine, you're going to be okay. As long as you're not matching, as long as they don't match up. All right. What other questions?
He said there's a lag.
Is there? 7 and 3. I mean, he's trying to get me to do all of them.
No, I think he was talking about the factors.
Oh, I gotcha.
Hey, Alex, somebody else is here. She said, oh my god, I didn't see all this.
What other questions y'all got? What other questions? What other questions? I'm gonna put this candle out because I'm afraid I'm gonna throw that paper over there right on the candle.
Okay, yeah, you move that paper.
What other questions?
Well, he asked her.
Oh, he asked her.
Yeah.
Alice, can you take that one? Is LSU shut down?
I don't think. Marshall.
You already put that? It ain't far off from here either. In my opinion. I think once one state goes to martial law, a lot of them are going to follow suit. Everybody's afraid to be the first.
Hoda, fucking Nala. Move. You don't want to jump down, I'm not picking back up.
Any questions? Any questions? Coda, come here. Coda, come here. Coda.
You see how mad he is?
Yeah, Coda. Coda. Coda Serapis. Coda. He is pouting. He is pouting. Come here.
Please don't.
Come here. Finally. Come here.
You're whine.
Yeah, he's a little whiny baby. There. Your fans can see you now. Nala's jealous. See her eyes?
Yeah, his eyes are.
Ugh. He is grumpy. He's mad because Nala's in Mama's lap, and he wants to be in Mama's lap. That's his spot. You see Nala? She's like, wait, what's going on over there?
I feel bad.
Yeah, I know he's from the state. You said it before.
Oh gosh. Only good thing is alcohol laws at LSU.
What are you doing?
Yeah, they were like, my mom said something yesterday. She was like Louisiana bad. I was like, yeah, because everybody went to Mardi Gras.
Everybody went to Mardi Gras.
Yeah, and I was like, the only reason why it's not as worse than what it is.
I agree with your assessment on the food there, Garen. I like parts of their food. My daughter doesn't like any of it, and she lives there.
Stop.
So if I go offline, it is Coda's fault because he is moving the tripod and everything else.
It's fine, like.
No, it's not. He's knocked it off.
Yes, listen.
All right.
Oh, didn't go to the natty for free. Yeah, but like the food is all like, it's the area you grew up in, what you grew up eating. You can't eat seafood, allergic to it.
Yeah, well, she's allergic to shellfish, not all seafood.
Personally.
Yeah. I do not have a bulletproof glass.
I've met Joe Burrow and Grant Delpit. Yes, you have at his birthday party, right?
Mm-hmm. At Tigerland.
No.
Oh. Any questions? Really, at this point, not much, because if you're on this page, you're asking a question on this page, that covers all the other pages because this page is a review.
Oh, I feel you.
Did you say not Tigerland? DL Tigerland?
And she said, "Don't expose me like I'll go to Tigerland." Dead poet. That's what it was. Yes.
What is a dead poet? Is that another club?
Yes. Tigerland is. I go in there. Remember when we went to go visit her one time? Waiting.
Uh-huh. Number 8. Number 8. We Garen already worked 9 and 10. Number 8 is a lot like number 9. I don't want to do all his work for him.
When he gets it done, obviously your questions has.
All right, I'll do 8 just because I'm bored. All right, here we go. X over. Let me get rid of this minus sign. X over 2x plus 7 minus x plus 1 over x plus 3 equals 1. Tyson might be allowed in Dead Poet next semester. I don't even know what HBCU is. Alright, so I need to get a common denominator. I know my common denominator is going to be 2x plus 7 times x plus 3. So I'm going to get x times x plus 3 over or minus my x plus 1 times 2x plus 7. That's all I did was I multiply up here and I multiply up here because if I multiply the bottoms I get my common denominator. So I got 2x plus 7 and x plus 3. That takes care of this side. This is all I did right here. I multiplied up. Y'all see me do this in class. And then here, 1, well, hey, I can write this as a 1 because I can say 2x plus 7 times x plus 3 divided by 2x plus 7 x plus 3. I just rewrote this because it's still just 1. If you divide it out, that's just 1. Now I have a common denominator, and I can actually say x cannot equal, let's see, this is going to be negative 7 halves and negative 3. That's easy enough. So I know what's going to be a possible extraneous solution. From here, let's just clean things up. I've got x squared. I'm going to use the property of equality, so I'm only going to mess with the numerator. X squared plus 3x minus, this gives me 2x squared plus 7 plus 2 plus 9x plus 7. And that's going to equal, let's see, 2x squared plus 6 plus 7 plus 13x plus 21. So we have x squared plus 3x minus 2x squared minus 9x minus 7 equals 2x squared plus 13x plus 21. Basic math here. Combine like terms. I've got negative x squared plus minus 6x minus 7 equals 2x squared plus 13x plus 21. Move all these over. I'm going to get 0 equals 3x squared plus 19x plus 28. And then from there, I think you can finish it out. Just factor it if it factors. Yeah. You can finish it from there. That's the hard part. All the hard part's done. Now it's down to a quadratic, and you can just solve it.
BC, historically black college.
Oh, did not know that.
Right, I'm telling you, something's happening.
Why?
Just early. Do you want up or no?
It could be that they were shutting the military down earlier than normal, instead of 5, maybe 3.
Maybe. But why would they do it like back to back to back to back to back? Normally it's just one and done.
No idea. Trump's press conference is still probably going on right now. What else?
The HP are awesome.
The bands.
Oh, I didn't read that part.
Yeah, the bands.
I got you. Oh, okay. I got you. Military.
Oh. That means Omar is going to be really slow.
No, because like more people aren't listening, so more people are out. When I went there earlier. You're busy.
Oh, this is why. So Alex said Preston's drills this weekend got canceled, and then Garen said my uncle is. So everything's fluid right now. Everything's fluid. I really just think it's Alex, you, Garen, and somebody else. Somebody just watching. Because there's 4. It doesn't count me.
Had the opportunity. You jumped on twice. I went and got Nala back up, so you just policy.
Oh, really? Oh yeah, it shows your name in a different color because you're a moderator. You know, we can have him zoom in if your daughter knows how to do Zoom. But I could do a Zoom real quick and have her in here. I can give her the code.
Wait, Ethan Rice was here?
Yes. Yeah, I helped him with the math problem in his college class. Pretty basic problem. Does she want to Zoom? Zoom in, Tyson? I am. I'm waiting for her. You want to zoom in, Tyson? We have all three dogs? Oh. Man.
Sure.
Okay. Give me a second. I'll text you the code that you can join.
If you because
It was a
middle
school principal. Hold on, where's my bow? All right. So I'm about to text you the meeting ID.
Yeah, that sucks.
What?
He said they can't even. Oh yeah, sucks. That's 46:39.
It is not walking weather.
Got their sweaters on.
Not walking weather for me. Alice, I just text you the meeting ID. Yeah. I need to switch. Yeah. All right, give me a second.
Tells me. Hot.
There you go. Just sent it.
It still says he needs.
Can't help you, man. Can't help you with English. Maybe my daughter can help you with some English, or my wife can help you with some English, but I can't. Oh, there she is. Give her a second. Okay, hold on. Yeah, give me a second. I know, I see you. It's a different camera.
Oh, there it is. I see you. I see you.
Hey, we're live. Watch your language. Can I make that? No, but up there. I had to because I couldn't use both cameras. I've seen if I can just do hers. I guess not. Not inviting you, buddy. Wow, I can barely see. Your lighting sucks, Alex.
The light's off.
Jeez.
Oh, that LSU stuff. Oh, look at the baby.
Is he feeling better? No, he's still coughing. Giving him his medicine. He's being a baby.
She matches her wall.
What do you mean she matches? What do you mean? Oh, I got you.
Tyson baby. Oh. Hey. Tyson, I miss you. Oh. Tyson.
Oh, his ears went up. Tyson. Oh, that's too cute. You see his ears go up? Oh, it's recording it. It'll be on my YouTube thing. Huh? Would you ask, Alex? Coming for Coda's fame? No. Somebody actually asked for Coda in the chat.
Yesterday.
Darren said he loves Huskies. Man, nobody's got questions. I guess after we're done talking with her, he looks so sad. He looks so sad.
You want to give a room tour of your posters?
Tyson.
Tyson. Boy.
Number 5. So you want number 5?
Not right. Guys.
Right.
You're right.
Right here. All right, so number 5. Let me make sure I'm in the right spot. All right, right there.
Coda's back.
Coda's back.
Tyson. Show me Tyson.
X squared minus 4x minus 5 all over x plus 5 divided by x squared plus 6x plus 5. All right. So this one is it is laggy. Wow. That's laggy. I think because I have a lot going on my computer. Yeah, I've got like 3 things going on. All right, so step 1, factor everything. So this is going to give me x minus... x minus 5, x plus 1 over x plus 5, and I wrote 15, divided by, well, this factors to x plus 1, x plus 5. All right, from here we can see this is really over 1, so we know x cannot equal negative 5. Then we're going to change and flip, so we're going to have x minus 5 times x plus 1 over x plus 5. Change my division to times. This becomes 1 over x plus 1, x plus 5. Let's look to simplify. Well, actually, let's look. Is there any x's we can exclude still? Well, we've got negative 5, which is good, and now also negative 1. And then let's look to cancel. Up and down, nothing cancels. Up and down, nothing cancels. Diagonal here, nothing cancels. Diagonal here, my x plus 1s go away. This just simply leaves me with x minus 5 over x plus 5 squared, because there's 2 of them. And you're done. And then your domain is the set of all x's such that x is an element of the real numbers. And x cannot equal negative 5 and negative 1. Done. Not terribly bad. No, he's not frozen.
But it's like Inception, because like inside your Zoom meeting one, you can see yourself doing the problem on some of your laptop screen. So I'm like watching you, so like I see you in like 3 different places. Tyson! You good boy? You wanna be good boy? I saw your ears. You get excited when Whitman started coughing? Baby.
Garen's saying it's really laggy.
No, it's not your show.
That was your last one right there? That works for me, buddy.
No, that's not your show right now.
It is 54, so I can shut down the stream here shortly. And keep the Zoom going with my daughter.
Did you not see what that bit? No, because you started writing.
Oh, I gotcha.
Oh, so it's like it coming in at different times?
Yeah, because it's laggy a little bit. I think it's just I've got my computer doing way too much stuff right now.
Tyson.
Like in OBS right now, I've got 1, 2, 3 cameras, the chat.
It's not about you.
I gotcha.
Tyson. And Eli.
Coda, come here. Coda, let's get all 3 dogs on the stream. Coda. Coda, I'm over here, moron. Coda.
Standing before you pick him up so he doesn't fight you.
Hey, come on. Let's go. Stand up. Come on. Come here. Come here.
He took off.
Come here. Ready? 1, 2,
He started running down the hallway.
And then he ran into the wall.
I heard that.
Look, it's Coda.
Oh, look at all the babies. Look, there's your brothers. Your brothers. Oh, the husky. Tyson.
Tyson.
Tyson. Tyson.
Well, he is lazy.
I know.
You can tell he does not feel well.
Tyson, you want a treat?
You want a bath? Tyson, you want a bath?
Makes him go in his condo.
Oh, I'm just trying to get him to go crazy eye.
I want you to kiss at him. Got corona.
Well, he has been coughing. You never know.
Tyson.
Look, right here. Coda. Coda. Hey. Alright, I want to end the stream. Garen. And Alex, I'm going to keep the Zoom up, but I'm going to end the stream real quick. So,